Consider the next problem. Show that the integral represents the indicated function integral 0 to infinity sin pi omega sin omega x by 1 minus omega square d omega equal to pi by 2 sin x if 0 less than x less than pi, 0 if x greater than pi. Here given a function and denote this function as f of x. We have to prove that this f of x is equal to the integral 0 to infinity sin pi omega sin omega x by 1 minus omega square d omega. Okay, just observe that here sin pi omega is a constant. Sin pi omega is a constant and sin omega x is a variable function. Here the variable function is only sin omega x. So to prove this equality we have to use Fourier sine integral equation. Okay, and Fourier sine integral is f of x equal to integral 0 to infinity b omega sin omega x d omega, where b omega equal to 2 by pi integral 0 to infinity f of v sin omega v dv. Here the interval is 0 to pi, so substitute here 0 to pi by 2 into f of v, that is pi by 2 into sin v sin omega v dv. Here this function is of the form 2 sin a sin b. 2 sin a sin b is cos a minus b minus cos a plus b. Using that trigonometric equation, separate the terms sin v sin omega v as in this form 1 by 2 into cos v minus omega v minus cos v plus omega v dv. Then separate, integrate and substitute the limits. We get b omega as sin omega pi by 1 minus omega square. Therefore f of x equal to integral 0 to infinity, substitute b omega here, we get we can prove like this. Okay, next consider the next problem. Show that integral 0 to infinity sin omega minus omega cos omega by omega square sin omega x d omega equal to pi by 2x 0 less than x less than 1, pi by 4 when x equal to 1, 0 when x greater than 1. Here the variable function sin omega minus omega cos omega is constant and the variable function is sin omega x only. So we have to use Fourier sine integral. Using that equation, find b omega and substitute that value in f of x, we get the equality. Okay, next problem, third. In this question the variable functions are cos omega x and sin omega x. This function contains both the terms, so we have to use Fourier integrals. So we have to find a omega, b omega and substitute in f of x. Next, last problem. Show that e raised to minus x into cos x equal to 2 by pi integral 0 to infinity omega square plus 2 into cos omega x by omega square plus 4 d omega. Here the variable function is cos omega x only, so we have to use Fourier cosine integral to prove that. Okay, similar way we can do the other problems. Just try that. Okay.